Hey guys, we are going to do a quick little lesson on mass percent. I just want to make sure you know how to use the formula so you can try out the calculations on your own if you need to. And this ties right into molar mass. So this is our formula we're going to be working with. The mass of the part divided by the mass of the whole times 100. You might remember utilizing a little bit over the summer. So this says what is the percent composition by mass of each element in sodium phosphate. So the first thing you're going to have to be able to do is actually write that formula for sodium phosphate. So Na3 PO4 based on sodium ions having a +1 charge and phosphate ions having a -3 charge. The other thing we're going to need to know is the molar mass of the whole compound. So using your periodic tables, your molar mass is going to be equal to 3 times the mass of sodium, which is 22.99, plus the mass of 1 phosphorus, 30.97, plus the mass of 4 oxygen, which is your 16.00. When you add those up, you're going to get how many grams were in 1 mole of our substance. And going to the hundredths place here, we get 163.94 grams per mole. So that would be the mass of 1 mole of it. So think of that as 100% is the full compound. So if we want to know the percent composition by mass of, say, sodium, okay, I'm going to do the molar mass of my 3 sodium. So you do have to take into account the fact that in every one, compound, you have 3 sodium ions, or in every 1 mole of the compound, you have 3 moles of sodium ions. So with this, then I'm going to show 3 times the molar mass of a sodium ion, which is that 22.99, divided by the mass of my whole compound, or my molar mass in this case. And then I'm going to do my times 100. So because it's asking for the percent composition, I'm going to multiply by 100. If I wanted the mass fraction, I would simply leave out that times 100. And then I would go ahead and calculate my answer. Usually with percentages, I will go to the hundredth spot. A percent I really don't think of as in terms of precision and representing the accuracy in terms of the instruments when I do the percent. So I usually like to go to the hundredths. All right, I would then do this for my other 2. So I have 1 phosphorus in the compound, which has a molar mass of 30.97, divided by the molar mass of my whole compound. And that gives me my 18.89%. Okay, and then finally I would have my oxygen. I have 4 oxygen, so 4 times 16.00 divided by the mass of my molar mass of my whole compound times 100. And then I should get here 39.04%. And ideally those should add up to 100% or be incredibly close to it based on rounding. So that's just finding the percent composition of each of those elements. What that then allows us to do is, if you look in number 2, it says, well, say we have 225 gram sample of sodium phosphate. How many grams of that are just phosphorus? Well, we can use the percent composition formula to find this out. So we know based on our calculation up above that 18.87% of that is going to be phosphorus. So I'm going to put my percentage over there. I'm just going to use the formula for this. Some of you guys would be able to do this a little bit simpler. Put my mass, in this case, my given mass of the whole compound, 225 grams. And then I want to know, well, of that 225 grams, how much of it is phosphorus? And I know it's that 18.87% of it. So after I divide my 18.87 divided by 100, you can think of cross multiplying. At that case, X here would be equal to 42.5 grams of phosphorus. Okay, so we can use those percentages in order to actually look at our masses in the lab. So that's all there really is to it. The rest of the page is going to be a very similar process, so you should be all set.